This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make wind turbine lightning protection easy. If you're a wind farm operator, stop settling for damaged turbine blades and constant downtime. Get your uptime back with our Strike Tape lightning protection system. Learn more in today's show notes or visit weatherguardwind.com/striketape.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. I'm your co-host, Dan Blewett. On today's show, we have a great guest. Henrik Lund Nielsen is here. He is the founder and general manager of Cobod International. So let's first talk about the company a little bit. So Cobod is a really interesting, it's a disruptive 3D construction printing company. So they're creating the technology, the 3D printers themselves, to do concrete 3D printing, which is currently being used for just in the general construction sector, building houses. They built a 2-story apartment building. So they're capable of building all sorts of structures. They're also, this is one of the big things we'll talk about today, in the wind industry, building wind turbine bases. So they can build a wider base on site that is going to allow wind turbines to get significantly taller because they have that wider base. So that's currently a bottleneck in the construction process of onshore wind. So it's a really interesting solution. Cobod is partnering with GE on the wind turbine base project. They're also partners with Lafarge, which is the largest concrete manufacturer in the world, for their different types of concrete, because this has to be a flowable, high strength. There's a lot of really interesting things that we'll talk about today in the show. A lot of interesting aspects to the concrete material itself. You can't just take something off the shelf from your local hardware store and expect that to work. So there's a lot of high-tech stuff, not just the 3D printer technology itself, but also the materials, like I said, the concrete and the additives to them, and then just what different types of projects can they complete, and the architecture of all those. Really, really fascinating. All right, so a little bit more about our guest today, Henrik Lund Nielsen. So he is a graduate of the Copenhagen Business School, also has an MBA from what is now Alliant International University. He was longtime CEO of Gypsum Recycling International. He's been a board member of numerous companies, CEO of a number of other companies. He's also the founder of the 3D Print Ventures, A&S. And he's, of course, founder and general manager of Cobod International. So lots of experience managing people in the economic disruption space. And he's highly interested in disruptive technologies that can, make the world better and make economic sense on a much bigger scale. So that's, again, a large piece of the conversation today about how 3D printing can just make a lot of projects faster, more economical, and also have a more positive local impact. So you set up a printer in another country, train workers locally, use local materials. That's a big part of this mission of Cobod. So without further ado, we're going to jump into our conversation today with Henrik Lund Nielsen, founder and general manager of Cobod International. All right, Henrik, thank you so much for coming on the show. We really appreciate it.
No worries.
So obviously you are out in Denmark, and I mean, this is, that's wind power is essentially in your blood, right?
That's true. Most Danish people have long life love with windmills.
Mm-hmm. Well, and you've an interesting childhood story. So you mentioned you have a connection actually a little bit with the CEO of Vestas. You two grew up together, is that right?
Yeah, we grew up together, and when we turned 18 and had to write our social thesis assignment in high school, we chose to write about windmills, which at that time, we were speaking about almost 40 years ago, was mostly something that was supported by hippie movement, the kind of the leftovers from the Woodstock period and so on, and then a few farmers. So definitely normal conservative industry was dead set against it. But I've always loved it, and I think it's a no-brainer that you put something up and then you generate the energy out of a resource that doesn't cost anything. So from an economic point of view, I think it's wonderful. And I've been in love with it since I was 18. And then we wrote that thesis together with the guy that then, my good friend, that then ended up becoming the CEO of Vestas. Quite funny also.
Yeah, it's crazy how you never know where you're going to go in life, and these crazy parallels even decades later. So you're the one of the founders, and you're the general manager of Cobod. And as you just mentioned, this stuff isn't just for, in the wind industry specifically, it's not just for hippies anymore. This is a big commercial business, right? And you're focused heavily on economic improvement and economic disruption. So can you talk a little bit about how your technology at Cobod is going to disrupt and improve not just wind, but really you're looking much bigger at the economic footprint that your tech can provide?
Mm-hmm. Well, you can say there are some very heavy logistical constraints when you want to do tall towers, because the towers are so-called conical shape. That means they have a diameter which is larger at the base than at the top. So the taller you go, as there's a minimum diameter at the top, the taller you go, the wider the base becomes. However, in most countries, also in the US, you cannot transport anything that is more than 4.5 meters in diameter. And that puts a natural limit at the towers for being up to 80 meters. So anything that is made in a factory and has to be pre-assembled in a factory and then shipped like that will run into trouble around the 80 meters. Whereas our factory is on wheel. We can put up a printer anywhere. We take a truck out with a printer, and then we set it up anywhere, and we can print 10 meters wide bases, or 12 meter, or 15 meter wide bases.
Yeah, so let's talk about that. So obviously, we mentioned this 3D printing construction technology back in one of our shows, I think in June. And like you said, the solution is helping wind turbines grow taller, because now we can do a lot of this construction on site. But can you describe the actual technology itself? So the BOD 2 is your new printer. How does that all work? How does it get set up on a construction site? So if a wind, and we'll get to GE a little bit because they're your big partner on the wind side right now. But let's talk about what the technology looks like right now.
Okay. BOD 2 is our second generation printer. With our first generation, we 3D printed the first 3D printed building in Europe back in 2017. But we were not satisfied with it, so we developed the BOD 2 instead. It's modular build of modules of 2.5 meters, so around 8 feet if you're measuring feet. So you go in any direction with 2.5 meters with a maximum width of 15 meters, so 50 feet, and a maximum height right now of 33 feet or 10 meters, whereas in the length you can go as long as you like. You just add more modules and more Z-axis.
Okay. And so for those of you out here, this is obviously 3D construction and printing, and you're probably familiar. This is becoming a much more mainstream, right? I know, years ago, 3D printing was just little plastic, whether it was little devices or trinkets or construction, or not construction pieces, but it was a very smaller scale thing. And it's been around for a couple of decades.
The principle of the printers is still the same. You move on 3 axes at the same time, X, Y, and Z. So in the width, in the length, and in the height.
Yeah, and
we just made them many times bigger than what you've seen before. The longest we made so far was 27 meters.
Yeah.
In the length.
So let's talk about that progression too. So obviously, there are now tabletop versions of 3D printers. So I could buy one today. It'd be here, in a couple of days. I could print things out of plastic, potentially metal even. And you identified this a long time ago, and you said this could be used for construction. We could pump concrete through this 3D printer and maybe build a house, build a school, build all sorts of different buildings, and it has a lot of limitations removed, like we said, with the wind turbine bases, but also construction in general. What were some of those other limitations, and why did you see this not infantile, but this technology in its infancy, and say we could do this on a huge scale for construction?
We already made printers of polymer printers with of the dimension of 1 to 2 meters and so on. So in that sense, the step was not as far for us. The first printer we made was approximately 7 by 7 by 7 meters. But the principles are the same. But what is critical is that you have a material that is first flowable, because then you can transport it in hoses. Mm-hmm. And then once it comes out of the extrusion, the print nozzle, as we call it, being extruded, it very fast cures up and becomes hard. So you need that, let's say, fluid, solid transition to happen quite fast. So in the cheap printers you're speaking about, you're doing it with plastics that you heat up, and therefore it becomes flowable. And then when it dries down, it becomes hard. Same thing with concrete. We found out that concrete, when it's made, is fluid, it's flowable, but it can be made to harden pretty quickly, and then you can build with it.
So let's jump to, so we have a lot to cover today. You have such a unique story with Cobot and your different partners. Let's jump to Lafarge. So they're the biggest concrete supplier in the world. Tell us a little bit about the concrete, because you can't just take anything off the shelf. I'm sure you couldn't just run down to the local hardware store and say this concrete's going to work in our printer.
No, correct. So this project that we are doing with GE as the end customer, if you like. That's run by 3 partners in a fantastic, I would have to describe it as an excellent cooperation between the partners. So we each have our field. Our field obviously is the 3D printing technology. The field of Lafarge is obviously the materials and so on. Like we are undergoing a development with our technology, upscaling it and industrializing it, because these windmill towers are very tall and they require a lot of concrete. Then at the same time, Lafarge on their side is upscaling and upgrading their concrete. So moving from, let's say, less strong concretes to more and more strong concretes, and also concretes that are easier to mix, to pump, but still can have that ability to cure up pretty fast. This is a special science, and it's nothing that we could do on our own, and so we're very grateful for that. Lafarge also saw a possibility in this and would join this joint cooperation that we have with GE.
Yeah, and this was one of the questions I had for you before, which is, what role does your company have within a construction site using, your 3D printer? So you aren't necessarily designing the building, you are supplying or maybe you're supplying the tools, right? You're supplying the 3D printer for a company to say, so if I have my construction company, I say, hey, I want to build a house. You sell me the 3D printer, and then, but maybe we cooperate and we develop the project so that, okay, let's work with Lafarge so we have the right concrete. Let's work with other teams. So can you tell me a little bit about that process? Where do you exactly come in to this whole thing?
No, you're entirely correct. We are the tech supplier. So we are a tech company. We are not a construction company. So in our building construction area of our business, we are basically selling 3D construction printers to our customers that are then executing projects with the help of our printers. But we are not doing it actively on site ourselves. So the role that we play on site normally in a normal construction project is zero, because we just supply the necessary printer, and then our customers are applying it. In the case of GE, it's a little bit different because this is still very immature, and not a lot of people have tried 3D printing windmills before. In fact, we are the only one who's ever done it before. So hence we are taking the lead role in that. But during this year, there will be a transition where other people will actually man our printers, so that even the construction of the newer prototypes that we're going to do this year will not be done by our guys in front. We will be there to supervise, but we will not be the ones that are manning the printer, etc. So we're training local crews in the U.S. to be able to do these jobs.
Oh, that's interesting. So that's a big change for you. I mean, it's sort of like, all right, we've given the tools, we've given the training, and now let's see how it works.
First time we did it, which was with our first Bot 2 printer back in January 19, we were a little bit doubtful of how it would go, because it's brand new technology, never been applied before, and so on. And our customer, Camsey, doesn't have their own construction workers. It's a kind of R&D innovation center, so they don't have construction workers. Instead, they took students from the nearby university. Then we trained the students. The students trained other students, and these students made the first two-story building in Europe.
Wow.
But quite funny, we trained students that trained other students, and then they did it. So that sort of proved to us that, hey, it even if it seems science fiction and so on, it's not that hard. I mean, we can basically train anybody that is IT skilled or engineer skilled to master the printer within a week.
Yeah. So before we go back to GE, because I have a couple more questions for you about it. That is a really interesting aspect of it. This is not back-breaking construction labor, which is a really positive thing, right? And it's also really interesting where I'm sure lots of younger people, the millennial generation, everyone has, they're coming up with this tech background, right? I didn't grow up with a smartphone. I know you didn't, but these kids do, right? And so they're coming into this world where they're a lot more tech savvy from the get-go. So, I mean, do you see the worker who, in construction, is it changing? I mean, this seems like it could really take off where, hey, I want to work in construction because this printer is super cool. I'm on the forefront of this new technology. We could do good things with it. We could print really cheap buildings and do good for, small communities and communities that need a new, whatever it is. I mean, I feel like there's a lot of applications where the human aspect could be really excited about this.
That's correct. Well, you asked a lot of questions at the same time.
I did.
I'll try to provide two answers. Number one, as to the popularity of working with tech like we are supplying. Yes, there is no doubt. I mean, if you look at my own recruitment situation, we are Danish by birth, and still 50% of our employees are Danish, but the other 50% are internationals, and we basically hire the best we can get. And we get a lot of applications from the whole world, from young people that just wants to work with this technology. This is very, very different from the construction sector. The construction sector in all the developed countries, the US including, the Germany, Denmark, Japan, Korea, they're all seeing a shortage of new entries into the construction sector. So in particular in Japan, for instance, you have a very high percent of the workforce. I think it's actually 30% of their workforce, construction workforce, is retiring within 10 years, and they can't get new entrants.
Yeah.
So young people that wants to do construction work because it's hard and it's not pleasant working conditions, and you get worn out. And our technology solves that. So because it's not physically damaging to you or stressing you in any way. So a lot of our customers are also seeing this as a chance to overcome that lack of skilled labor, because all the skills are in the printer. So that's the first part of the answer.
Yeah.
The second part of the answer is the millenniums. Sure, like my kids, they've almost grown up with a tablet, and you know what? You can control the printer with the tablet. So whether it's a TikTok program you're controlling through your laptop or the printer, it's as easy. It is as easy. The whole thing is made automatic. Huh?
Yeah. So obviously this iteration of your technology, it's not the first, right? We talked about there's different types. So, there's robotic, the gantry arms, and then there's your method. Can you talk about the two and why you've chosen the one that you've settled on?
Sure. Within concrete printing, there are basically two schools. One is the robotic arm school, where you print in front of yourself. You print fairly small elements, typically maximum of 4 feet in the width and a couple of feet in the depth, and maybe 8 feet in the height. Mm-hmm. And then you piece these elements together to make an entirety, so to say. Whereas our printer, you set them up at the around the entire thing that you want to print. You set it up once, and then you print the whole thing. There are no connections between parts, etc. It's made in one go. It was clear to us that if you wanted to move into large construction objects like buildings, houses, 2 stories, 3 stories, windmills, etc., the gantry solution would be the robotic arm solution, very, very superior. Mm-hmm. Where the robotic arm solution is superior is if you have to make very intricate, very artistic, smaller single objects, like a very twisted column or something like that.
Yeah.
There, the robotic arm, with its less size, it's more precision because it can move around in 6 axes, whereas we move on 4 axes. There, the robotic arm, I think, has a relevance. I don't think it has a relevance in making entire buildings.
Gotcha. So I want to jump back to GE here. So obviously, I know there's some things you can't talk about, and there's a lot of really interesting, new tech, perhaps under NDA. But let's talk a little bit more about just getting this wind turbine base up and tested, because one of the things I think that's interesting is that there aren't 3D printed. There's not many 3D printed structures out there, right? This is it's on the forefront. So one of the chief questions is, how do we know it's not going to fall down, right? You have a huge wind turbine on top of this base in high winds. There's lots of stresses and forces. How did you test that out, and what was that process like to say, hey, this is solid?
Obviously, there's not only been one test, there's been multiple tests. I think an even better guarantee you get is that you get certifiers involved when it comes to the real thing, when it has to be made in the real world application. You get a certifier involved, in this case, DNVGL, and they certify that this building method that we are doing with the kind of rebar, the kind of concrete, with this and this documented strengths, etc., that will be safe to use. So you have a whole certification process going on. We've not reached that stage yet. We'll get there, but we haven't reached it yet.
Gotcha. And then, is it a situation where, because again, I know we talked a little bit about outside the box and inside the box, and would you describe what you're doing? It's obviously it's new technology and it's really interesting, but would you describe it as really outside the box as far as construction, or is it still kind of inside the box?
No, it's disruptive within the box, so to say, because we are disrupting the way you are manufacturing, but you're using technologies and methods that have been used before. So you're using a concrete material, you're using steel cages as rebar or steel tendons as rebar. And those are what has always been used in concrete towers. And that's why, in that sense, it's within the box. You could also go outside of the box and say, well, with this technology, we have completely new solutions for making, for instance, reinforcement solutions that we haven't seen before. So we do glass fiber reinforced wire or something like that, which has not been applied before. And we have a parallel process also looking outside the box, not just inside the box.
Gotcha. Okay, that makes sense.
But the inside the box will make you have a commercial viable product much faster. Because when you're outside the box, it's all new, and you need to test and prove much more, of course.
Yeah, that makes sense. So let's talk about speed a little bit. So, say, in the future, a wind site's going up and they say, hey, we've got 80 turbines and we want to get, we need as many 3D printers as we can get to get this up. With traditional manufacturing or construction, it could take months or years, right? It's going to take probably a couple years to get all the construction done. What's typical the speed increase with, say they had 80 wind turbines. Let's just go with that number. Is it 5? Is it 10 printers, and they could hammer them out in a matter of weeks instead of months and years? What can they expect?
It all depends on how much capital cost that you want, because obviously, like we spoke about before, the printer can be moved from site to site, but within the site, it can also easily be moved, right? So the fewer of the printers that you apply, the longer it will obviously take. But our ambition is to look at making a tower in a week, which is a huge improvement in terms of the first 80 meters. We will do that. Our ambition is to do that within a week, and I can try to put that into perspective. The first tower we did in 19 for GE. It was a 10-meter tower, so 33 feet tower of 100 tons. They still, even if we did the first prototype, they were skeptical as to could it really be correct that you could put up a printer and then print a 10-meter tower in a short period of time. We knew we could because we had been doing other things. We were a little bit disappointed about the speed. So we predicted that the next time we would have to do the same tower, we could cut it down from 3 weeks to 3 days. Now, in the meantime, then a year is passing. A lot of things were upgraded, made more industrial, so in terms of pumps and mixers. And then the design changed. So instead of being 100 tons now, the 10-meter, it was 175 tons, so 75% more. And by the way, we should also remember that we just had to apply, while we were printing, so at the same time, 8 tons of reinforcement. Now, we did that. We did it in 3 days and 4 hours. So
Wow.
you can say we did 75% more in 1/7 of the time. That's a 12-time improvement in productivity from the first time to the second time. So obviously, if we did it a third time, we could do it even faster, and the fourth time even faster, and so on. And that's why we from Cobot's side at least, we're thinking, okay, 80 meter, let's do it in a week.
Yeah. So 3 weeks down to 3 days was your first progression.
Yeah, but with 75% more material. Right?
Yeah.
So they printed 75% more, despite the fact you went from 3 weeks to 3 days.
So let's talk about the worker aspect of that. So obviously a lot of these wind sites and construction projects in general, right? If you're going to build a couple of houses in a very remote rural area or up really high up in the mountains and in a hospitable place, traditionally you'd have to send a big construction team and they might be there for months or years on end. How would that potentially change with 3D printing?
There's no doubt for a lot of these sites, and the more the sites are growing in size, the more remote you are getting. And when you're remote, there's no doubt that the deployment of the crews is a very, very significant. You can call it logistical cost or whatever you want to call it, deployment cost.
Mm-hmm.
And clearly, when you then can cut down on time with the help of our technology, you can cut down on that per time unit. Expensive deployment of the crews. So also in that sense, we will help to cut down costs.
Yeah, and one of the interesting things that I was thinking that's probably overlooked quite a bit is if you're going to do a site in, say, in another country, like say it's in South America, there might be a lot of, say you want to import, a base that's made of concrete or import a tower. Does that pose problems doing that, importing?
Some of the biggest markets in the world, Brazil, India, and so on, they have high import barriers for steel. So if there's no local steel plant close by, it doesn't help that you are in one end of Brazil having a steel plant, and then you are doing a project at the other end because inland transportation is also extremely costly. So there might be, a plant somewhere in Mexico and it would be cheaper to ship from there. But the problem is then you're hit by import barriers, import tariffs. So we also localize production, and that means we're creating jobs locally with the help of our technology. And that is actually a demand in a lot of these tenders, that there is a certain percentage of local content in the execution of the project. So in that sense, it's good also that you use local people and create local jobs instead of importing people from all kinds of places. Of course, you still need to have some experts involved that's coming from abroad, but you can use a large base of local people also.
Yeah, so if you had a project in Brazil, for example, you might have to import all those steel bases, but with a 3D printer, you could say, hey, we're going to set up here and we're going to make it all locally from local aggregate, mix the concrete locally and train the workers locally. And that could probably, do you feel like that's potentially going to allow a lot, not only projects faster, but more governments are going to approve these? It's going to reduce the cost in general? For
sure, yes. And then also think about the CO2 friendliness of that.
Mm-hmm.
As compared to shipping materials or finished products wide distances. So concrete printing is in itself CO2 friendly because you use resources that are close to your site and you don't transport it unnecessarily to a factory first, and then you transport the elements, and then you use a crane to get the elements in place, etc., etc. Mm-hmm. So it's much more CO2 friendly that way also.
Gotcha. And if there's a lot of concrete casting that had to be done, or you might potentially have to put up a factory in a local area. Is that right? And this could potentially alleviate that issue as well.
Yeah. If for certain reasons you cannot make steel towers, and you have to make a concrete plant, then you're looking at 50 million euros, so 60 million US dollars. establish the plant, and what do you then use the plant for afterwards? In essence, you have the same problem when you build tunnels and bridges.
Or the Olympics.
In a lot of cases, in a lot of cases, you have to build a factory, next to it in a harbor if it's a tunnel, right? But what do you then use that factory for afterwards? So we can move the printer to wherever it's needed. When you're finished with it in one side, you take it down, you take it to the next side.
Gotcha. So if more, obviously with GE being, they're the front runner in this, they're your partner at the moment, they're trying to get this technology up and running and viable for them. What barriers will other companies, say some construction company says, hey, yeah, we want to be involved in this. What are the barriers for them to suddenly be competent to say, yeah, we have the skills, we have the resources to build, whether it's a wind site for their own turbines or whether it's buildings for their construction company?
Sure. But if you speak about the construction companies, then there are no barriers, because I'm sure that GE would be happy to work with, let's say, the most competitive construction companies in that area where they have to do projects, right? So again, it's not us who's going to be doing it. We're going to sell the printers. It's going to be GE's, and then GE is going to apply them with the help of local construction companies all over the world. So for the construction companies, there are, in essence, there are no barriers. There's just a new way to make the towers, and they don't have to fund all this development, which is funded by GE, but also by grants. Among others, there's a Department of Energy grant from the U.S. that is backing this project that we're having.
Okay. So let's talk about other applications within wind energy. So it's not just towers, right? I know potentially foundations could be maybe on your radar. And what about offshore? But let's start with foundations first.
Yes. Well, foundations are really interesting application, because right now you can say, we are looking at, and the way that windmills are designed is that two separate pieces. You have the tower piece, and then you have the foundation, which is a very wide thing. So it's not untypical that while you have the 4.5 meter maximum diameter here, when you talk about the foundation, it's 25 meters. Now, what would happen if we thought out this thing as one combined unit and made it as one? What advantages would that be given? And initial calculations are showing that it's a very, very promising use of the technology also. But we have to, we like a baby. We're learning how to run here. First we have to crawl, and probably we'll learn to crawl now. And soon we have to start walking. And then after that, we can learn how to run. So but we have to take it step by step. And then that also goes for the offshore, because obviously offshore is hugely interesting application, especially here in Europe, where we have a lot of sea, but not many sites where you can put up new windmills. That's very different from the U.S., where you have these Midwest and Texas and so on. You have these mass areas where you can put up a lot of windmills where you're not bothering anybody. That's much more difficult in Europe. So that's why offshore is so popular in Europe, whereas in the US you don't have that much coastline relative to your population. Mm-hmm. So the land application is more attractive in the US, which is also why it's no wonder that it was GE that is spearheading this technology, because the land application is so important in the US.
Gotcha. I mean, do you see this potentially being, 3D printers on the coast and just printing things that might have typically been precast and then taken them offshore? They might sink them. They might
everywhere, Ben. I see it everywhere. There's no end to where I can see it. Mm-hmm. Obviously, we have to learn how to do it, and we have to overcome some barriers. And there's no magic here. It's hard work and development, and people that are believing it, and money and finance to be able to do it. But yes, I can see that happening too. I can even see us printing on ships, on boats, and then lowering it down and so on.
Wow, that's interesting. So let's talk about that. You said you mentioned people believing in it, and you have some pretty powerful, big, strong clients, right? I mean, and partners here. So LafargeHolcim is one of the biggest, the biggest concrete manufacturer, right? And GE is obviously a huge wind turbine manufacturer. But you also had another big one, a construction and a home hardware company, really help, they really believed in you earlier.
The German Perry Group, which is making what is known as formwork equipment. If you want to cast concrete on site, in the past, you were either doing it with manual, you try to make some molds with the help of wood, or you would buy formwork equipment. And Perry is the leading company globally within the supply of formwork equipment. They very quickly realized that we're also casting on site. In essence, that's what we're doing. We're casting concrete on site, and basically the same as application as they're pursuing. But we're doing it automatic, and they are doing it with manual solutions. And they predicted very quickly that wow, this technology is going to take a large share of the construction market. So it's better to join these guys than to try to beat them. So Perry came in very early, back in 2018, and has been tremendously important for us. Both in terms of giving credibility and so on, but it's a 2 billion euros or so sales company, 10,000 employees, 80 superiors around the world. Obviously, they come in with all their know-how and knowledge of the construction industry, of concrete and of casting and so on, and we have benefited tremendously from that.
Gotcha. Yeah, I mean, it seems like that's always a big part of it. Like you have to have like the early adopters, and obviously for like tech and lots of little devices, everyone, there are some people who are the early adopters of an iPhone, right? Like the geeks. But in your case, these are some big companies that were like, we see the same. We see what Henrik sees.
I need to applaud Perry Group, because what they did was they did a disruptive arm of their own company. Said we make a disruptive, new technologies, disruptive arm of our own company, and we give them the assignment to go around out there in the market, find all the technologies that can threaten us with what we're doing now, and then we will invest in them. And for a family-run German company, that's really, really impressive to have that kind of vision. So yes, and again, tremendously important for us in terms of credibility, because now it was not just these tech guys from Denmark that knew a lot about 3D printing, but not so much about construction. It was backed by one of the most important companies within the construction sector on a global scale.
Yeah, and then you have that sort of that hand on your shoulder that's like, hey, we've got all the years and the huge team behind Perry Group to
basically
help
they're
us.
saying to us, tell us what you need, and we'll help you. So tremendous support, fantastic. I would say the same thing goes also for Lafarge. It's a little later in the process, but Lafarge has also been a tremendous partner to work with, and GE also. And yes, we are lucky. We do have some tremendous customers. I can mention L&T Construction in India, which is India's largest construction company with 135,000 employees.
Wow.
And, we have numerous of these companies with 10, 20, 40,000 employees, which is backing us and our solution, which is, of course, very satisfying for us as a company.
Gotcha. So I do want to turn back to one more line of questioning in wind energy, which is distributed wind, the small wind turbines. I mean, do you see this, your printers what are they typically, would they be something accessible to say one farm wanted to put up one small wind turbine? Is this going to make sense at that scale, or is it only going to make sense at a bigger commercial scale?
No, I think it will make sense also there. And there is clearly a development going. And obviously we are spearheading that together with GE to go taller and bigger, also in terms of the printers, right? Mm-hmm. So I could foresee at a certain point that we could do, for instance, a 30-meter windmill. And you have markets for that. I'm not too familiar with it in the US, but I know in Europe there's a regional market for those kind of windmills. And yes, again, as the deployment of the technology as fast as it is, you set it up, you print fast, you take it down again fast, and then you're out of it. Yes, I can definitely see that happening.
Gotcha. Yeah, we had Paul Dawson from EOCycle on the show a couple episodes back, and he was, their company is in distributed wind. So these 25 kilowatt, smaller wind turbines that can power, 5 to 10 homes or a small business. So yeah, I could see it having applications there.
But a 30-meter tall windmill can power a lot more than that.
This is true. This is true. Yeah, I think you said there. You and your meters. The U.S. needs to just get on. We just need to get on. We just get on meters. Well, it's funny. It's funny because it. No, I mean, I want you to speak in your terms, but it's funny because you hear the word 30 and you think, oh, that's not that tall, but 30 meters is pretty darn tall. I mean, that's
that is 100 feet.
99 feet.
I can very easily. Not a problem.
So, well, let's talk about
all over the globe. I have to be very international in the way I am. So
you're very imperial metric fluid. Yeah. Well, let's talk about the future. Obviously, you're still only a couple iterations into your technology. I mean, what are some challenges that you're facing? Where do you still want to improve, and where do you hope to be in a couple of years?
Mm-hmm. Well, the challenges we are facing is traditional conservatism of the construction industry. So the construction industry is used to that they make a product that has to last at least 30 years. And here on this side of the pond in Europe, we built to last. That means there's no end date for the buildings, etc. They just last hundreds and hundreds of years. And we have lots of buildings like that, both here and the rest of Europe. Because of that, then there is a natural tendency to not just plunge into any new technology that shows up and any new building method, because, hang on, let's just see that it's there, a year, 2 years after, because we have to vouch for our product for so long. So that tends to grow a natural conservatism. Again, luckily, because of the backing of Perry and Lafarge and similar companies, we're overcoming it more and more, I would say, and can really see a change here in the last couple of years. That's one challenge. Another challenge is permitting, because all the building codes was written around the old-fashioned technology, and now we come with a new technology that can do it way smarter in a lot of ways, but we're not allowed to by the building code. So quite often we have to go around the code and do something a little bit stupid just to be able to make the code happy. So,
gotcha.
So I would like to see the changes in the building codes happening faster. It is ongoing. It has been recognized that this must happen because this new technology is dominating more, or it's not dominating, but it's becoming more and more available, and it's making more and more buildings and so on. But it's probably a 5 to 8 year process.
Yeah,
so
I didn't think about that.
Sorry.
Yeah, that's interesting that the inspectors and just the regulations have to catch up with something that's very, very new. Yeah, that makes sense.
Yeah, but that's typical. That has happened also in the aviation industry, where, by the way, GE is also very big with metal 3D printing of parts.
Yeah.
They also had to, do a lot to prove that the 3D printed metal parts were as strong as the casted metal part and so on. So regulations are always behind technology. Then it's never ahead of technology. So in terms of where we want to go, obviously we want to go faster, wider, taller, and that's a continuous process, and we are very much developing in that direction. But we also want to go deeper in the sense that within the building, why should we limit ourselves to just do what we can extrude? Why can't our printers, or maybe we should call them construction robotics, why can't they hold a spray gun and then we do painting? Or why can't we do insulation while we are there anyway? So we see this development inwards, so to say, in terms of doing more and more functionality, to build in more and more functionality to the printers. And then we see this taller, wider, faster development, typical for new technology.
Yeah, that's an interesting idea, that not only the structure of a new house or building, but also as you're going, like, hey, this is curing. Let's, like you said, let's insulate. Let's add in some windows. Let's start to, because there's a lot of, there's so many. The order of operations and the construction checklist is so long. So yeah, that's an interesting idea.
Process.
Yeah,
it's a very complex process. There's a lot of manual labor involved. So we're looking at the processes that requires the most manual labor, and then we are investigating how could we automate that. Because something that's done very quickly is no sense in automating, but something which requires a lot of labor, that makes sense automating.
Gotcha. Well, and as we wrap up here, I know there's one other thing that you're passionate about, which is reducing CO2 and helping the planet. Would you like to speak a little bit about your mission with that?
Well, I've always been. I'm green from an economic point of view. So it started. Obviously, you could say with the windmills, where you have a free resources of wind. Let's get the best out of that. But you can make the parallel into waste, especially in the U.S. You might not know it, but you guys are very wasteful, and all of your waste more or less end up in landfills. Here in Europe, at least, we are pretty good at burning it for energy. But even converting it into energy because you're burning it, if you think about it, you take paper and plastic and you put it into an oven. Why don't we, recycle it back into paper and plastic so we don't have to use new resources? That to me, economically, must be a much better plan. Anything that can help to reduce CO2 and this project that we're doing with Lafarge and GE is definitely also doing that, because the taller you go with your windmills, the more you harvest of the energy. So of the wind up there. So you can increase the output from the same windmill just by extending it. You can increase the output with 20 or 30%. So in essence, from a CO2 point of view, it more or less required the same amount of CO2 to make the windmill, but now your output of it is increased with 20 and 30%. And obviously, every time we make more wind energy, we reduce the dependency on fossil fuels. So that's also, from that point of view, extremely good.
Yeah. Well, that's an important part of it, because I think, especially here in the U.S., you see more and more companies integrating this environmentalism with their corporate, mission. So I think, obviously, in the
here you can't avoid it. If you don't speak about being green and being environmentally friendly and low carbon footprint, you're dead. So at least you have to speak about it. But whether you then actually do so much about it is maybe another matter for a lot of industries. But you need to at least show that you care and that you are thinking about it and so on.
Well, and as we kind of double back to the mention of millennial workers, they're more than I think probably any other generation really driven by purpose. So they don't want to just work for a construction company and just build a building. They want to build a building that's also helping the environment and, meeting some of those environmental goals. So I think it always continues to tie back into it. The more, you as general manager of a large disruptive company that's doing good for the planet and, no buts about it, you're outspoken about it. I think that helps that same recruitment cycle. Young people want to be involved in things that don't just earn them a paycheck, but also are giving back to the environment. They know that when I'm running the printer, I'm helping the planet. I'm doing, my part, and not just for my family, my paycheck, and my financial stability.
But it's also a sign of an affluent country or affluent society. The richer you as a country become, the more you can afford to look at non-financial things. Whereas, if you are fighting in Africa for your everyday life, then it's very, very difficult to be CO2 friendly. And unfortunately, we see that. We see that there is a lot of damage going on in Africa and other developing countries or parts of the world, not so developed, where, because the whole focus is on, just getting by and making sure you get hot food and so on, that we're not applying the best practices that we could.
Well, Henrik, this has been a fantastic conversation. I really appreciate your time. I think this is such an interesting technology. I watched all your YouTube videos and, following around. The time lapses are fascinating.
Many more.
Yeah. So we'll for sure link to all that stuff in the description below, so you can follow up with Cobod and with their technology, because it really is, it's fascinating, and it really is a very interesting development in construction, not just for the wind industry, but for the planet. So thank you again for being on the show. And again, really appreciate your time.
No problem. Happy to be here.
All right, that's it for our episode of the Uptime Podcast. I want to thank again today's guest, Henrik Lund Nielsen from Cobod International. Be sure to check out the description links, whether you're listening on podcast platforms such as iTunes, Spotify, Stitcher, and other, or here on YouTube. Be sure to check out the description links below, where you can link out and watch some of Cobod's pretty amazing videos. You can check out their company and you can find ways to get in touch with them if you'd like to. Obviously, please subscribe to the channel, share the show with a friend. This is a really fascinating episode. So if you know someone who geeks out on new technology like this, or is just really passionate about reducing CO2 in the atmosphere, and obviously with green energy, then definitely share the show, because like I said, this is something that's going to be more and more prevalent. It's really exciting, interesting technology, and we hope to see more of it in the future. Thanks again for listening, and we will see you here next time on the Uptime Wind Energy Podcast. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.